Hey. Alright, today we got one more rule for taking the derivative of a complicated function. We had the product rule and the quotient rule. The third one is actually the most important. It's the chain rule. This is about how do you take the derivative of one function plugged inside of another. This is the derivative of a composition. Hear that squeaks? I don't know what that's about. Composition means one function inside of another function. Kind of like this. How about x squared plus 5x all to the 10th power? This is what we call a composition of functions. One function inside of another function. Here we have kind of this is the inside thing. And then on the outside is this 10th power. So here x squared plus 5x is inside, and the 10th power is outside, right? Generally speaking, I want to know, how do you take the derivative of something like that? Hopefully it has something to do with this function, which is on the inside, and this function, which is on the outside. And there's some formula about how you use the derivative of each of those two parts to get the derivative of the whole thing. Really what we're talking about is, what is the derivative of something like this? The derivative of a function on the outside and then another function on the inside of that thing. F of g of x. How do you do the derivative of a thing on the inside and a thing on the outside? I'll tell you how to do it. First of all, you should not think about the product rule here. I'm not talking about f of x times g of x. For that, you would use the product rule. But here, I have g of x inside of f of x. What do we do with that? Well, there's another rule for that. It's called the chain rule. Here it is. It's f prime of g of x times g prime of x. All right? This is the formula for the chain rule. This is how you handle one function inside of another function. In words, how I would describe this is, you do the derivative of the outside with the same inside. That's this part, right? The derivative of the outside with the same thing on the inside. And then times g prime of x. So times derivative of the inside. All right? That's how I would remember this, sort of in words. Actually, I don't really memorize this as a formula, although you can if you want to. For me, I find it more helpful to memorize this little slogan here. You take the derivative of the thing on the outside, leaving the same thing on the inside, and then you multiply by the derivative of the inside. All right? Let's just try an example. How about that one I just said before? Actually, I forgot what I said. This is similar, I guess. X squared plus 5x to the 10. Is that exactly what I said? I don't know. How do we do this? First, you got to decide for yourself, what is the inside and what is the outside? Well, I wrote it down before. The inside is this thing, x squared plus 5x. The outside is the 10th power, all right? That's why one reason why it's maybe not so helpful to memorize this as a formula. Here, the f is actually the 10th power, right? Even though the f appears like first to the left in this formula here, f represents the thing on the outside, and in this case, that thing is written on the right hand side. It's not the thing you see first over here. Anyway, the 10th power is the outside part. The inside part is this x squared plus 5x. Let's do the chain rule then. So you take the derivative of the outside part, which is the 10th power. So I'm going to do the derivative of the 10th power. That is to say, you bring the 10 down to the front. You decrease this power to a 9. And what do you leave on the inside? The same inside is what the formula says. So it looks like this. This is what I mean when I say you take the derivative on the outside and you leave the same thing on the inside. Don't also take the derivative in here. That's a rookie mistake. The same thing on the inside. All right, and then, that was just this part, then times the derivative of the inside. Times, what is the derivative of the inside? The derivative of x squared plus 5x is easy. That's 2x plus 5. And that's the answer. This is the derivative of that thing right there. All right, this is how you do the chain rule. I hope you put those parentheses there. It is necessary. It'll be different if you leave out those parentheses. All right, this is the chain rule. And that's really all I wanted to go over today. Let's just do a couple more examples, and that should really do it. All right, I got, as usual, two examples. One's easy, one's hard. Let's do the easy one. The easy one is just very similar to what I did before. How about this? Derivative of the square root 2x to the minus 1 plus 3. All right, I said this is very similar to the one I just did, although it looks kind of different because of that square root sign. But as always, we are not going to write the square root as a root like that. It's much better to write it as a 1/2 power. So I am immediately going to change this to that with the 1/2 power. And now, I hope you agree, it does look just like the one we did before. Remember the one we had was like a polynomial in here and then a 10th power? It's a 1/2 power, but it doesn't matter. We do the chain rule exactly in the example we just did. So I do the derivative on the outside first. That means bring the 1/2 down with the same thing on the inside, and then you decrease the power by 1. I get minus 1/2. That's the first part of the chain rule. I did the derivative of the outer part with the same thing on the inside, and then times the derivative of the inside. And what is the derivative of the inside? You go minus 2x to the minus 2. Plus 3 goes away because it's a constant. So there you go. This is the derivative of this thing. That was the easy one. Let's do the harder one. All right, here's the harder one. Derivative of x times x squared plus 2x to the 7. That whole thing to the 10. All right? This is a little weird. If it were just that much, then it would be fine, right? Just this, you would use the chain rule just like the two examples we already did. But the fact that it has an extra x on there, that really does make a difference. This x, of course, is being multiplied onto there. And so we are going to use the product rule. All right, I have two things which are multiplied together. The thing you do in that situation is the product rule. So let's just do it. I hope you remember your product rule. It is the derivative of that thing should be the first part, which is x, times the derivative of the second part. My two parts in the product are like this, right? The first part is x, the second part is this, including the 10th power. I'm doing the product rule. The first thing, which is x, times derivative of the second thing. How am I going to do the derivative of this? Well, that I do with the chain rule. This is very much like the examples we've already done. So this is going to be a chain rule right here when I'm taking the derivative of the second part. I do the outer derivative first, 10 x squared plus 2x to the 7 to the 9. All right, that's this part, derivative of the outside with the same thing on the inside, and then I multiply times the derivative of the inside, which in this case would be 2x plus 14x to the 6. All right, so these inside these square brackets is the derivative of the second part here in the product rule, and I did that using the chain rule. This is not my final answer. Remember, overall I'm doing the product rule. I do the first thing, which was x, derivative of the second thing is all of that, and now the rest of the product rule, plus the second part as is, x squared plus 2x to the 7 to the 10, times the derivative of the first part. Derivative of x is just 1. All right, there you go. That's the answer. This is the derivative of that thing. A little complicated here. As usual, you could try to simplify this thing, although I don't see any reason why you should, unless somebody tells you to. I would say just leave your answer like this. This is the derivative. That's really all there is to it, the chain rule.